x coordinate, and then I have height residuals as the y coordinate. So I'm plotting the output against the error, essentially. And I put x equals 0, or y equals 0 here, so you can see which are positive, which of the residuals are positive and which are negative. This is way too much. This is far too much pattern. This should look like random noise, and you'll see when we build a better model of this that we're able to make this be random noise. This is a major take-home message. You never want the residuals to show a clear pattern. If they do, this means there is some aspect of the data that your model is failing to capture. It's clear that what's missing is a quadratic. So there's a pre-processing part of sklearn, and it has a polynomial features command. And in a minute let's just do that for now. So what polynomial features does is it takes a data frame and it adds the polynomial features that you might want. So let's do a real quick demonstration of this. I could do something like x equals np.array 1, 2, 3 reshape -1, 1. I think I need values maybe. Do I need series? Help me here. Oh, I'm trying to use NumPy and it's not there. Okay, import NumPy as np. So we can create a real quick, let's call this example, equals np.array 1, 2, 3, and I can use the polynomial features, so I can say polyfit example equal polynomial features degree equal 2. And what this does is it adds on a degree 2 term, and it makes it so that I can turn example into, so then it's polyfit example shift tab. So what does it take in? It takes in a degree, and it takes in include bias. And you can see here what the example looks like. You need to do fit transform, so we'll do fit transform example, and it says that expected a 2D array, got a 1D array, of course, so reshape -1, 1, and I want to say, okay, we'll talk about that in a second. So polyfit example, and then I can fit transform on the example. So what do you see here? Well, you have a column of all ones, and then you have my original 1, 2, 3, and it's showing up now as a column here. And then you have my new, which is 1 squared, 2 squared, 3 squared. So this is putting it into the data. Now you have a 1, an x, and an x squared. There's actually one thing I want to change about this, and I want to say include bias equals false, because I don't want this column of all ones. So if I run these next few again, remember the bias term is what we might call the intercept or the constant term. By saying include bias equals false, I'm saying just don't include this column of all ones. Okay, so now that we have some idea of, or we've at least seen how polynomial features works, we're going to use that. And so now let's add quadratic features, which just means that we're going to add on a new column that squares the variable to our height data. Now you've noticed I'm not doing train and test data. I probably still should, but I'm just trying to illustrate one feature right now, or one aspect of this right now. So let's say what I'm going to do is I'm going to do polyfit equals polynomial features degree equal 2, and include bias equal false. And I'm not going to fit transform it yet. Instead, what I'm going to do is I'm going to go ahead and create a placeholder for a quadratic model. Now, the QM stands for what a quadratic model, what a polynomial model looks like is a multilinear model on polynomial features, on the polynomial transformations that you've made of the variables. So QM stands for quadratic model. Okay, and it looks like it believes that I have not, sorry, linear regression is what that is called. So I'm creating a linear regression object that can do linear regression things, and I'm actually going to combine these into a pipeline. So a pipeline is something we're going to talk about more, but it's a really useful way of combining multiple steps of a data process. So I'm going to say from sklearning.pipeline import make pipeline, from sklearn.pipeline import make pipeline, and now I am going to say quad pipeline equals make pipeline polyfit qm. Now I have what's called a pipeline, and I can actually now use this pipeline. So what does the pipeline do? The first step of it transforms the data so that the data works well with a polynomial. And then the second step actually fits the polynomial to the data that's been transformed. So what a pipeline does, a pipeline enables me to do data transformation and regression in one process, because what I'm doing is I'm creating something that can do more than one thing. It can do the polynomial feature fitting, and it can do the quadratic regression by linear regression on the features. So let's back up here. Now let's say, I don't remember all of the quad pipeline code off the top of my head. Okay, so a pipeline is, let me call this quadreg, that's a better. Quadreg stands for quadratic regression, and now a pipeline is able to fit. So I can do quadreg.fit, and I'm going to say time data. So it tells me I have a pipeline that has no memory, and it has two steps. The first one is called polynomial features. Second one is called linear regression. And what I've done here is I've created a model that does two things at once. It converts to the data so it can be fit with polynomial, and then it actually does the polynomial fit. So now what I want is I want qm.coefs. So inside of this pipeline there's a qm model that just fit. So I see I have two coefficients, and that's because I have two variables as far as this model is concerned. I have the x variable and I have the x squared variable. And if you look way back at our first example here, when we applied polynomial features, the first column was the x variable and the second column was the x squared variable. So this tells me that the coefficient on x is roughly 30.004, and I've written this down here. And the coefficient on x squared is roughly negative 1.000, and I've written that down here. And then if I do qm.intercept, I see that the intercept of this model is 9.992, and I've written that down here. So we can see that the quadratic regression that we've done predicts that height can be predicted from time by this polynomial formula.